In this video, I am going to solve the problem 20th from chapter 26. The figure gives the electric potential V of x along a copper wire carrying uniform current. From a point of higher potential, V of S is equal to 12 microvolt at x is equal to 0 to a point of zero potential at x of S is equal to 3 meter. The wire has the radius of 2.2 millimeter, and what is the current in the wire? So here the information is given in the graph. So here the graph is given in terms of V versus X. So V is the potential. So the maximum potential at X is equal to 0 here is 12 microvolt. Likewise, at zero potential, the X of S is equal to 3 meter. So here the X indicates the length of the wire, and here V indicates the potential. So now what we are going to do, we are going to find what should be the current in the wire. And the material we are going to use in the wire is the copper wire. So we have to use the electric resistivity of the copper wire. So first of all, I'm going to write the given first, and after that, I'm going to apply the rule. So what is given in the question? In this question, they give the information about the potential. So what is the potential? The maximum potential here given as 12 microvolt. That means 12 multiply 10 power minus 6 volt. And here the length, the maximum length here is given. This is our length. So X of S is here mentioned as 3 meter. So the length of the wire here is 3 meter. And the radius of the wire is given, the cross-sectional area of the wire, because we are going to find the cross-sectional area. So for that we need the radius, right? So the radius here, they mention here as 2.2 millimeter. By using this radius, we are going to find what should be the cross-sectional area of the copper wire. So I have to convert this millimeter in terms of meter. So 2.2 multiply 10 power minus 3 meter. So anyhow, we have to calculate the area. So first of all, I'm going to find the area. If you see the cross-sectional wire, if you see the cross-sectional area of the wire, it looks like area of the circle. So area of the circle formula is pi r square, and here the radius is given. So therefore pi multiplied by the radius here is 2.2 multiply 10 power minus 3 the whole square. If you calculate, the value of the area is equal to 1.52 multiply 10 power minus 5 meter square. So this is the area. We just got the area by using the radius of the copper wire. And here the material is copper. So the resistivity of the copper is 1.69. It's a constant value. So 1.69 multiply 10 power minus 8 ohm meter. By using all these, we are going to find what should be the current in the wire. That means we are going to calculate the value of I. As we know, voltage, which is equal to current multiplied by the resistance. If you rearrange this in terms of current, therefore current is equal to voltage over resistance. So here voltage is already given in the question, but the resistance we have to find. So how we can find? In theory we studied the resistance we calculated by using this relation rho multiply L over area. So now what I am going to do, I am going to take this resistance formula, I am going to substitute here. If you substitute the above expression, that means the current expression is changed as V over rho multiplied by L over area, and this area will go to the top. By that, the equation will become as voltage multiplied by area over the resistivity of the copper multiplied by the length of the copper wire. Now I am going to substitute the value here. Potential, the maximum potential is given, which is 12 microvolts, right? So that means 12 multiply 10 power minus 6. And here the area, just before we found which is 1.52 multiply 10 power minus 5. I'm going to use that value here. 1.52 multiply 10 power minus 2, sorry, minus 5 over the resistivity of the copper wire is 1.69 multiply 10 power minus 8 multiply with the length, the maximum length of the wire. In the graph they mention as 3 meter, right? So now I'm going to calculate what should be the current. So here I got the answer for the current as 3.60 multiply 10 power minus 3 ampere. So this much of current is in the copper wire. So this is the answer for this question. That's it. Thank you.